Hello everybody, my name is Petr Hradil and I'm recording this video for the second webinar of the European project Accord. I will be talking about a proof of concept tool for automated checking of carbon footprint of the BIM models. If we want to calculate the carbon footprint of the building today, we can already use BIM, and there are many tools and services to assist with this work. Unfortunately, it still needs a lot of manual effort, which is obviously expensive and time-consuming. But what if we don't want to calculate the carbon footprint of the building, but just answer the question if the carbon footprint is lower than the limit? Actually, this is exactly the question that the building authorities are interested in. For this purpose, a conservative estimation of the carbon footprint might be totally sufficient. And if it is good enough, the check is passed. So here we are trying to demonstrate that such estimation is possible to obtain automatically without any user interaction and demanding requirement on the model. This specific demonstration is prepared for the new Finnish legislation, which entered into force in the beginning of 2025. According to the new Building Act, the new projects will have to provide a climate declaration with the calculation of the whole life carbon footprint and carbon handprint. Also, BIM models will have to be submitted for the building permit. Carbon footprint is basically extract of LCA calculation according to EN 15978, covering product stages A1 to A5, parts of the use stage of the building related to material replacement and energy use B4 and B6, and the end of life stage C1 to C4. This can be obtained by most of the current commercial LCA tools. Carbon handprint describes the impacts beyond the current building system boundary, such as recycling, reuse, or carbonation effects. This specific value is defined in the Finnish carbon assessment methodology. Both impacts shall be declared in kilograms of CO2 per square meter of heated area of the building, and then for the building site separately. For this purpose, the Finnish Ministry of the Environment prepared a special decree on climate declaration, carbon assessment methodology, and online CO2 database. The limit values of carbon footprint are still under development, but we already know that this value, the total carbon footprint of some types of buildings, will be limited. The Finnish emissions database for construction is free and can be accessed online using the link above me. It contains unit impacts of common building materials and some products in kilograms of CO2 equivalent per kilogram, cubic meter, square meter, or per unit. It also contains carbon intensity of transport, construction, deconstruction, and waste processing of the materials. These are very conveniently provided as CO2 equivalent per square meter of the building. So the applicant doesn't need to know specific information such as transport distance for each material. Also, building services can be calculated from the provided average values per square meter of the building. This means that they don't need to be included in the model. Still, there is some information which is needed for the successful carbon calculation: building floor area, its energy consumption, identification of materials and products and their quantities. As you can see, most of the information could be obtained automatically from the common architecture BIM model. The material identifications and quantities might be a little bit more problematic, but we will talk about it in the following part of the presentation. The proof of concept tool that I'm going to introduce in this video extracts the information from the IFC file, combines it with the information from the LCA database, and generates the estimated carbon footprint of the building in JSON or Excel. Alternatively, it can also consume tabular data in JSON of the materials and their quantities instead of IFC model. So far, it does not look different from many of the existing tools. The specialty of this tool is that the whole process is totally automated and the results will be generated for virtually any IFC model. And the results will not be wrong, only more or less inaccurate depending on the quality of the model provided. The inaccuracy of the carbon prediction is always on the conservative side of the calculation. This means that the results will be always higher than the reality. This is very important if we want to check the carbon footprint against the limit, and we don't want to have false positive results. It also allows relatively low quality models to pass without future improvement. As you can imagine, the quality of the input is the essential measure of the quality of the prediction. So how do we deal with the model inaccuracies? And how do we guarantee that the prediction is always higher than the reality? Obviously, the material identification is the most problematic part. If the materials are not assigned to the products, it may be a problem. In such cases, the tool is selecting the most conservative, highest CO2 material relevant to the element type. It can still be sufficient to pass the limit of the building if some small objects do not have the material assigned at all. If the quantities are not declared in the model, they can be calculated. The conservative way is to use the bounding box of the IFC geometry, which is always bigger than the element itself. But in many cases, such as doors and windows, the difference might be acceptable. If the material name is not matching the official database records, we provide a dictionary of commonly used terms. But this is only a provisional solution. In the future, it will be really great to involve a large language model to do the job. Unfortunately, we cannot anticipate the carbon footprint of the entities that are completely missing in the model. This is still the responsibility of the applicant to provide as complete data as possible. Apart from the CO2 level, the applicant gets additional information about the performance of the model, especially the entities without recognizable materials or quantities and material names that were impossible to identify are important. This information should help the applicant to improve the model in the case that the estimated carbon footprint is so conservative that it is higher than the limit value. Here we have several examples of the calculated carbon footprint. From the left side, we have one industrial hall designed in Tekla structures. Then we have two office buildings, one from ArchiCAD and one from Revit, and one residential house designed in ArchiCAD. As you can see, the predicted CO2 level varies a lot. This is the reason why the prediction should not be used as a proper LCA calculation. Higher values are usually caused by a poor quality of the model. So here is the comparison of the model quality. The red part of the pie chart means the percentage of the calculated CO2 from the known materials. You can see that, for example, in the third building, over 80% of CO2 is based on overestimated carbon values. The blue part is the percentage of entities with known quantities, plus half of those where the volumes were calculated from the bounding boxes. You can see that the most problematic model is the one on the right. Even a small number of entities without proper geometry declaration caused a very large overestimation of the carbon footprint. Such model would most certainly not pass the limit. It is clear that the sensitivity to missing quantities is larger than to missing materials. This can be improved in the future, for example, by implementing more accurate volume calculation, for instance, some meshing algorithm. To summarize this presentation, we can say that the Accord tool is a nice demonstrator about what is possible to do regarding more automated compliance checking. It shows the way how to decrease the pressure on the architects by using conservative assumptions on the model imperfections. And of course, I have to say that the purpose of this tool is not to provide accurate CO2 prediction, just to check if the design data is sufficient to pass the limit. Thank you for your attention. And here you can find more information about our EU project Accord. And this is the list of our partners. Have a nice day.